In this lesson, we're going to review functions. So let's look at definitions. A function is a subset of relations. So relations are just sets of ordered pairs. Now a function is a relation in which each x value is paired with exactly one y value. So examples of functions would be things like y equals x squared. You input an x value, such as 2, you square that, and it outputs 4. Now, if you input -2, that also will output as 4, but each input is only outputting one y value, so it is indeed a function. Here are some different scenarios, and I'm asking, does it represent y as a function of x? So, my input is the height of a student, the output is the number of books that students own. I would argue that this is not a function because it is possible that you have two students of the same height. So let's say that you have somebody who is 5 foot 4 inches and they own 17 books, where there's another student who's 5 foot 4 inches and that student has 3 books. So I would say that each x value is not paired with exactly one y value. Here's an example of a mapping. And this is a function because each x value is paired with exactly one y value. If you have difficulty reading this, you would just list it out as ordered pairs, 3, -1, 0, 0, etc. When you're given a graph, you should know that you're looking at the vertical line test, which states if I draw a vertical line, it can only pass through the graph at one point. This is hitting twice, so this is not a function. It fails the vertical line test. This curve over here is a function because no matter where I draw it, it only passes through at one point. Yes, it passes the vertical line test. Sometimes you'll be given a equation, so my suggestion is first solve this equation, which would be, let's see, if I solve for y, I'd have y squared equals 1/3 x if I divide both sides by 3. And then I take the square root of each side, would be y equals the square root of 1/3 x, and the moment I take the square root in an equation, I need to remember to plug in plus or minus. And I'm going to say that this is not a function, and here's why. If I plug in an x value such as 27, I would have 1/3 times 27, which would be 9. And then plus or minus the square root of 9 would be plus or minus 3. So there are two different values, so 27 would be paired with both 3 and -3. So this is not a function. And I gave a specific reason why. To prove something is wrong, you just show one case where it doesn't work. I want to remind you of function notation. This notation here does not mean multiplication. It is read as f of x. It's another way of saying y equals. F is the most common letter you'll see, but you'll also see cases of g of x, h of x, or really any other combination. This is telling you that x is your independent variable and f of x is your dependent. You are given a quadratic function here, and you're told to evaluate each of the following values. So when we do g of 6, it means we're plugging in 6 wherever there is an x. I get 60 for the first. So just to make sure you understand what this means that there is an ordered pair, 6, 60, that falls on that curve. G of -1, again, I'm just plugging in -1 everywhere there's an x value. Just make sure you get parentheses where they belong. Be 1 minus 8 minus 24 would be -31. And finally, you can also plug in more than just a number. So this is g of -4x. So again, everywhere there was an x, I'm going to be replacing it with -4x. So when I square -4x, it's going to be positive 16x squared. You're distributing this outer exponent. 8 times negative 4x would be minus 32x. And I bring down the minus 24. I look for any like terms, and there are none, so g of negative 4x is equal to this quadratic expression. A huge part of understanding functions is being able to identify the domain and the range. So your domain is your set of all input or your x values. It would be your independent variable, and your range is the set of all y values or your output values, known as your dependent variable. So we are going to be determining the domain and range of some functions, and we're going to be expressing their answer in interval notation. So when I'm looking for domain, I kind of ask myself two questions. I'm thinking, so how far to the left does the graph go, and then how far to the right? So my strategy is I take a kind of a vertical line and I move it from left to right until I encounter my first value. And I think, what is this x value? Well, this point happens to be labeled for me, and the x is negative 3. So my first domain value is negative 3, and I'm going to put a bracket here because it's a closed circle. It's included in the graph. And as I move this, how far to the right? Well, I have values all along this curve, and you need to recognize that you're not always going to see an arrow at the end of a graph created by technology. So I'm going to assume here that this graph goes infinitely to the right, so it just keeps moving and moving and moving towards positive infinity. Cannot contain infinity, so I put a parentheses. Now for the range, I ask myself, how low to how high does the graph go? So as I'm making this, I draw a horizontal line. And I move this horizontal line from the bottom up to the top of the graph. So this graph goes down and down and down and down, but the highest it's ever going to reach is right here at that y value, which is 4. So since it drops forever, I'm going to say it goes negative infinity to positive 4, inclusive with the 4, but you can never include negative infinity, so parentheses and then a bracket. For this one here, domain and range, there is something interesting happening here. There's some breaks in my curve. It's what we call discontinuous, and I see some asymptotes, which you will learn more about. But I'm just going to kind of sketch them in here. There seems to be a break right here at positive 2. This curve gets really close to that positive 2, but it's never ever going to touch it. And this curve over here, again, as it goes up, it's going to get closer and closer, but never ever touch it. Same thing here horizontally. I also have what's known as a horizontal asymptote at 0. So again, my curve is going to get really close to 0. It's going to approach it infinitely, but never ever touch it. Same thing over here. Approach it infinitely, but never touch it. So my domain, left to right. Well, my curve here is going to go infinitely to the left. So I'm going to start by saying it goes from negative infinity, comma, how far to the right? Well, it keeps going, but it never ever touches this 2. And then it jumps over 2 and picks up over here. So since it never ever touches 2, 2 is not included. So it goes from negative infinity to 2. Union, it picks up again at positive 2. Again, not included. Gets really, really close, 2.000001 to positive infinity. Similarly, the range, how low to how high. This curve moves up and up and up and up, almost gets 0, jumps over 0, picks up over here, and goes infinitely upward. So my range would be negative infinity to 0, union 0 to infinity. So it's really everything except 0 is included in the range, and the domain is everything except 2. This is an example of a piecewise function. We're going to state the domain and the range. It is a function because it does pass the vertical line test. It does have 2 suspicious looking spots right here, open circle, but here it's a close, so it only hits once. Same thing right here, passes through this top one and hits here at 1, 3. So it is a function. So for the domain, as I move from left to right, my first point I encounter is negative 6, and that is included in the domain, so I place a bracket. How far to the right? Well, it picks up down here, moves along, jumps up here, moves, and here is the furthest value to the right, which is 4. So my domain values are -6 to 4. As I move for the range, how low? Here's my lowest value. How high does it go? Well, it jumps up here to 3. I've got values, jumps over here, all the way to +6, and this point here is an open circle. So I'm going from -6 inclusive to +6, and that is not included. Here's algebraically how a piecewise function can be written. It tells you for what domain values you are using, or what part of the function you're using for specified domain values. So when I'm told to evaluate f of -4, I first look at the domain, and that applies to these domain values, so it gets plugged into 1/2 x squared. So it'd be 1/2 times -4 squared would be 1/2 times 16, which is 8. F of 1/2, that's going to fall here in the middle between 0 and 2. And, well, that's going to be my horizontal line, -3, for that entire stretch. And then f of 8 gets plugged into, it's greater than 2, so it gets plugged into this bottom linear part of the function. So -3 times 8 plus 7 would evaluate to -17. Here is one more piecewise function. Take a second, try to evaluate it, and then check your answer. One thing that's just important to notice, f of -3, that domain value of -3, if you look here, this is for the value smaller. Here's where it's equal to. So it would need to be plugged into this one here. Actually, I believe the next one, f of 2, would be plugged into the last, and f of 0 would go into this middle one again. Okay, there is your review of what functions are, how to evaluate them, and how to express their domain and range in interval notation.